This problem covers a little bit of probability theory, and we have two six-sided dice. Each die has six possible numbers. We assume that these are fair dice and that each number is just as likely as the others. And it asks, what are the chances, what's the probability of rolling something between a 5 and an 8? Well, to do this, you have to know how likely it is to roll those numbers, 5, 6, 7, 8. And the way I want you to think about this is, first ask yourself, how many ways are there to roll a 5? Then we'll talk about the other numbers. And you can see I've drawn out some possibilities here. Maybe the first die has a 1. Well, that means you're going to need a 4 on the next die. Okay, that would give you a 5. Maybe you roll a 2, maybe you roll a 3, maybe you roll a 4. And for each one of those, you have a possibility here that would get you a 5 total. And the number of ways that there are to roll a 5, if you add them all up, are 4. There's 4 different possibilities. So I'm going to write that down here. And if you go through this same exercise and count how many ways you could roll a 6 on 2 dice, you're going to find 5 possible ways, right? Starting with a 1 and a 5, then a 2 and a 4, then a 3 and a 3, and so on. And then you can go through this procedure for each one of these things and find that total, the number of ways there are to roll either a 5 or a 6 or a 7 or an 8. It's actually quite a few ways you could do this. There's 20 possible results that would be one of those 4 numbers, 5, 6, 7, 8. Okay, so that's an important number. It tells us how many times we would expect to see one of these results. But the question is, out of how many dice rolls are there possible? Okay, so total number of dice rolls, that's a different idea. Total possibilities, well, we could sit here for a while and count them out, which might not be a bad exercise. You start with a 1 on one die. How many possible rolls are there on the other die? And I'm talking all of them, right? Of course, there's 6. And if you go to a 2, then there's still 6 possibilities, and a 3, and there's 6. So for every die on the left, there's 6 possibilities on the right, which means the total number of dice rolls possible is 36. Okay, so if I want to know the probability, and here's a general equation you can, did I spell that right? Yeah, probability. Here's a general equation you can find very useful. What are the number of successes divided by the number of possible outcomes? Okay, and that applies to all sorts of things. Like, let's say there's 2 ways I can win at a card game, but there's 10 possible outcomes of the card game. Well, you see, I'm not too likely to win, actually. It's maybe only about a 20% in that case. But in this case, there's 20 ways for me to win by getting a 5, 6, 7, or 8. And there's 36 possible outcomes. So that's my probability, 20 divided by 36. And if you just convert that into a percentage, and your calculator can do that pretty easily, you can see how this turns into one of these numbers on the table.